Recording now, this is lesson 3.3. Before watching the recording, please make sure that you have a graph sheet of paper with you, a pencil, and perhaps different colored pens and a highlighter. So if you need to grab those items, please do so now. I'm just going to continue, so just make sure you have the date written at the top of your page along with the title 3.3. And also write down the question that you see here on the screen. The purpose of this lesson is to expose you to different ways of estimation. Before we get into that, it's good to talk about when would you need to estimate. Now, think about situations in which you would need to estimate in real life, so beyond math class. And pause the recording. I'd like you to list down situations where you would need to estimate in real life. And in the follow-up class, we will go over what you've come up with in terms of these situations. I won't go over it specifically right now in the video, so pause the recording and then we'll continue on. Now, hopefully by now, you've come up with some different situations in which you would need to estimate in real life. So again, beyond math class. The second question, so that's question number 1. So question 2, I'd like you to write this down and we'll talk about the answer together, is what is the purpose of estimating? So again, what is the purpose of estimating? Why do we do it? Well, in math and also in real life, it helps you check if your answer makes sense. Now, this ties in really nicely to the first curricular competency that you're often assessed on, which is reasoning and analyzing. So when you estimate your answer before you do any calculation and you check your actual answer against your estimation, you're using that reasoning and analyzing component. So you're making sense of your answer. Does your answer make sense? It'll help you solve problems faster as well if you estimate. So that's kind of the second reason. Okay. So you're more efficient and it will help you make decisions when an exact answer isn't needed. So those are sort of the purposes behind estimation. And if you go beyond that, it's especially useful in real life, like when you're shopping, measuring, or you're planning time. So perhaps those are some situations that you listed in the answer to question number 1. Okay, so again, as I mentioned before, in this lesson, you're going to be exposed to different ways of estimating. And there are 3 main ways, and please be familiar with all 3 ways, just so that you're comfortable with and familiar with all of them, because you may have to use one versus the other in different situations. Now, the first way, actually, let's write down the title first. So 3 different ways to estimate. Okay, so again, 3 different ways to estimate. Okay, so the first one is called using decimal benchmarks. Okay, so I'm just going to highlight this. So decimal benchmarks. So what does that mean? You actually know this first way probably the best, and that means that you are just following the rules of rounding. Okay, By the way, there is no right or wrong way to estimate. And with any of these strategies, you're going to look at what is the best fit, or what is the best fit of or method in which you can estimate in that situation. So with decimal benchmarks, for example, and we're dealing with decimals now. So if say you had 5 and 75 hundredths times 6. Well, if you were to use decimal benchmarks, you're following the rules of rounding. You're not actually multiplying 5 and 75 hundredths times 6. And you want to estimate first before you calculate. So you're going to take the decimal and you're going to round it to the nearest whole number. So that's what I mean by following the rules of rounding. It's going to be 6. So 5.75 rounds to 6 times 6, which equals 36. So you know that when you actually calculate 5 and 75 hundredths times 6, your answer has to be around 36. I'd also like you to get into the habit of determining if your estimate is going to be over or under the actual answer. We know that 36 is an overestimate because you're bumping up 5 and 75 hundredths up to 6. Okay, so that's an overestimate. So this is an example of when we're following the rules of rounding. Okay. Another example would be, say, if you had to do with money, I always say you should always round up when you're dealing with money because of taxes. You want to allow for taxes or any additional fees. Say you had $11.25. Actually, not 25, sorry. Let's say $11.54 times 2. Because maybe you're purchasing 2 of that item. So here in this case, because you've got $11.54, you're rounding that to the nearest whole dollar, which would be $12 times 2. So that would be 24. Again, we're following the rules of rounding because we were dealing with 54 cents there. We know that's also going to be an overestimate. So again, following the rules of rounding, that's way number 1 to estimate is decimal benchmarks. Okay, the next way, which again, this is maybe a new way that you've been exposed to, is called front-end estimation. Okay, so this is, again, front-end estimation. I will highlight this. Now, front-end estimation definition is that you are using the place value of the front digits of a number. Okay, so again, front-end estimation means you're using the place value of the front digits of the numbers. So we're going to use the same first example as above here. Now, 5 and 75 hundredths, or 5.75 times 6. Now, all you're going to do is with front-end estimation, you just take the numbers before the decimal and you cut off the rest. You're not following the rules of rounding. So when you're doing front-end estimation for 5.75 times 6, you're actually not going to round up to 6. You're just going to take the 5 as it is. So it's going to be 5 times 6, which is 30. Okay, so we know that's going to be an underestimate because we've taken just the 5. It's not necessarily rounding down, but we know that our actual answer will be over 30 because we're not using the digits after the decimal. Okay, so front-end estimation does not typically follow the rules of rounding. You could have overlap. You could have a decimal benchmark and front-end estimation. Say if the first digit after the decimal in the tenth spot was 4 and below. Here's another example. So say you had, again, same thing, $11.54 times 2. And if you were just simply doing front-end estimation, you would leave this at $11 and not round it up to 12 because, again, you're not following the rules of rounding necessarily, times 2, which would give you 22. And so this is going to be also an underestimate. Now, so those are the first two ways of estimating. So you've got decimal benchmarks and you've got front-end estimation. Now, the third way in which we estimate, and I'm going to try to squeeze this in all on the same page, is what we call compatible numbers. And this is the most flexible of the estimation strategies and probably my favorite because it doesn't really follow any strict rules per se. So compatible numbers simply is when, okay, let me just highlight this here. Compatible numbers is basically you are using numbers, you use numbers that you can deal with easily, that are friendly. Oops, that you can deal with. Okay, I got the wrong setting there, that you can deal with easily. That's why it's compatible numbers. Okay, so numbers you can deal with easily, numbers that you can calculate in your head easily, like using in the mental math, essentially. I have to note here that anytime you estimate, the idea is that it should be estimating with numbers that you can easily calculate, which is why I find that this third way of estimating with compatible numbers, it's the easiest one to use because it's just you're working with numbers that are compatible. Now, I find too, though, sometimes with compatible numbers, your estimates might be further off, okay? So remember, there's no right or wrong way to estimate. You just have to be mindful of how accurate your estimate is. So here's an example. Okay, so say we have 19 and 34/100ths divided by 3. Now, if you were to use decimal benchmarks for this and you were to follow the rules of rounding, you would do 19 divided by 3, which again isn't the easiest thing to calculate in your head. 19 is not divisible by 3, so you're still dealing with decimal. So think about the closest number to 19 that is divisible by 3. And that's what I mean by compatible numbers. So I would actually take this maybe to 21. It is the higher, closer number that is divisible by 3. So if we did 21 divided by 3, we would get 7. And this would actually be an overestimate. Now, there's another compatible number that's close as well. So we could go low and go, okay, well, I also know that 18 is divisible by 3, and that's something I can calculate in my head. So 18 divided by 3 is 6, and that is an underestimate. So again, the thing to keep in mind when you're using the compatible number strategy of estimating is you're picking an estimate or you're picking a number that you can easily work with. It might not be the closest, therefore your estimates might not be as close as saying using a decimal benchmark or using front-end estimation, okay? So to review again the 3 different ways of estimating, we've got decimal benchmarks, where it's just following the rules of rounding. Be mindful if your estimate is over or under, okay? So in these 2 cases, we had 2 overestimates. Front-end estimation, you're simply just using the place value of the front digits before the decimal, okay? You're not looking at anything after it. You're just taking the front digit, okay, or digits. And finally, compatible numbers, which is the most flexible estimation strategy. So you're just using numbers that you can deal with easily. It emphasizes the use of your mental math. So again, with these 2, we're taking the closest number that's divisible by 3, that's closest to 19 and 34/100ths.